Hi everyone, this is our M2T3 review. So this is talking about system of equations and system of inequalities. It's going to cover all of that. And again, please do the work first. And then if you have questions, then look at this video. Or you can look at this video first and then try it on your own. But you really need to keep your brain thinking and help your brain to process by itself. So don't just copy along while I'm doing. Okay, sounds good. Here's number one. Floaters Company rents out boats for $10 an hour, plus $20 for supplies. Drifters Company rents out boats for $15 an hour, plus $10 for supplies. Which one would be better? So we're going to be writing some equations, but before we do that, down this screen just a little bit. Come on, buddies. It's going to go to I'm just going to go just a little bit. All right, so right here on the bottom, our X is talking about our the number of hours, right? Number of hours we will be renting. And our Y-axis is going to be talking about the amount of money, right? So total cost. Right? How much is it going to cost us as customers? Okay, so our first one, let's make them purple. So Floaters Co will be purple. We rent out our boats for $10 an hour plus 20 bucks, which means our $10 an hour keeps on repeating, right? Because every hour it's another $10. So that's going to be our slope. So it's going to be y is equal to 10x plus, and then our supplies is just the one-time fee. It doesn't look like we're doing it for every hour. We don't have to rent it for every hour, right? So it's just going to plus the 20 bucks, a straight $20, right? And we look at our second, the Drifters Co. They are charging, so again, it's going to be y is equal, ooh, that does not look like it. They're charging 15 bucks an hour, so a little bit more expensive. But the upside is, I don't know what's going on with my pen chip today, but there are some issues. So $15 an hour plus, assume that's a 15, please. But their supplies are a little bit cheaper, so it's going to be $10 for supplies. So which one's better? These are always the ones that we try to figure out. So let's graph this. We can graph this guy out. So let's take a look. We're starting at 20 bucks. So if we don't ever rent it, but we just want the supplies, that's 20 bucks right there. But now we're renting. So after 1 hour, that's going to be an additional 30 bucks, additional 30 bucks, additional 10 bucks, which goes to $30 altogether, right? And then so every hour it's another $10. Do you see our slope is 10 over 1? We're just going to go 10 over 1. You don't have to do all the dots, but it's just easier for me to draw the line. This is not a dashed line. It's just a solid line because we're in equations, not in inequalities. And then we're going to go do the second one. So this is going to be, we're starting at 10 bucks for just supplies. And every hour we're having to pay them $15 more, right? So from 10, we're going to go up 15. So going up to 10. And then that each box is $5, right? So 15. And then we're going to go up to 30 right here. Do this a couple more times. So basically 3 boxes is one is $15. I'm going up 3 over 1. I want to think about it that way. Here we go. We're going to draw this line. There we go. That's why we need rulers, but this is what we have. Okay, and then it asks us, what is a solution? What does it mean in this context? So in this case, the solution, when we have two lines like this, where they intersect, that is a solution. So this is a solution right here. That is going to be 2 and 40. So 240. And what does it mean in this context? So 2, remember, it's 2 hours. So we would say after 2 hours, both rental companies, I'm just going to say CO, will cost 40, 40 bucks. So both of them cost the same. So if we were to rent the boat for 2 hours, doesn't matter which company we go with, it's going to be the same amount. So it doesn't matter. But if we were going to go only for 1 hour, then which one would be better? The one that's lower, right? So if it was for 1 hour, then the orange one, which was Drifter Company, we would probably want to go with them. If we wanted to go anything more than 2 hours, then it would be much cheaper to go with the purple one, which is which one was it? Floaters Co. So Floaters Co. would be better if we're going to do anything more than 2 hours, right? You see how this is very helpful? Like I've actually used this before to see which one is cheaper. So for example, like literally this is what I had done one time with phone companies, right? Because which you want to know which one is cheaper. These are not the actual amounts. These are, well, for Horizon Cellular, not to be confused with the other company, but Horizon Cellular is charges 40 bucks activation fee, so that's like our one-time fee, and a $25 monthly fee, right? So $25 data plan, right? So every month it's $25. Assuming we're not going over overage charges and all that kind of stuff, right? Now Z Mobile charges a $70, let's use for this one, a $70 activation fee and a $15 monthly data plan. Now, which one's better, right? It depends. What's your thought on that? So here we go. Let's write the equation. I'm going to just write it over here. I know there's space on the bottom, but I'm just going to write it here so I don't have to keep on scrolling up and down. So, okay, let's go with Horizon Cellular. We're starting with how much is our monthly plan? $25. So 25x, we know that's going to be our slope because that's how much we have to pay every month. And our $40 activation fee is just a one-time charge, so it's just 40 bucks. And we're going to go with Z Mobile. And that's going to be, again, 15 times X, because $15 monthly charge plus 70 bucks for the activation fee. Their monthly is cheaper, but their activation fee is pretty large. It's almost double of Horizon Cellular, right? Which one's better? So let's graph this guy out. Again, we are going to be looking at the X. So this right here is going to be that. Remember, the X talks about the number of months, right? That we are using this company, right? And then the Y-axis talking about the total cost, not the total cost from 1 month, but the total cost overall. Like if we add them up like if we're doing a yearly budget, like how much do we need for the phone for 1 year? Like how much money does that cost? So that's what that is, not like monthly, how much it is. All right, so now let's graph this guy out. So here's Horizon Cellular. So we're starting at 40 bucks. So we just do it. We just activate it. It's not even been 1 month. We're paying 40 bucks, right? After 1 month of usage, we're paying that extra $25. So 40, so this is 10, 20, 25. So each box is 5. So 10, 20, 10, 20. I can't go anymore, so I'm just going to go like that. And then I'm going to just carefully graph this guy out. So that's going to be Horizon Cellular, how much it costs. So after 3 months, it will have cost me $115 altogether for those 3 months. And then let's do Z Mobile, starting at 70 bucks, so all the way up here. See how much different that is? But it's only going to be a $15 charge every month. It was 10, 5, so that's 15. 10, 5, 15. All right. See that the slope is slightly less steep. Okay, fine. My lines are not too bad here this time. So what is it called? What is the solution? The solution is where they meet, this part right here. So that's going to be at 3, 115. So 3, 115. So what does that mean? That means after 3 months, right? 3 months, they're both going to cost 115 bucks. So if I was planning on using, I only needed this plan for 3 months, doesn't matter which one I'm going to use because they both cost the same amount, right? So, so I'll say after 3 months, I didn't write 3. After 3 months, both phone companies cost $115, right? However, if I wanted, let's say I was somewhere else and I knew I was going to be moving soon, but I needed a cell phone company and I only needed it for like 2 months, right? So which one would I go with? I would go with the purple one, which is Horizon Cellular, right? Because that is cheaper than the other one. But if I knew I was going to be doing this, I'm not planning on moving, we're going to stay for a long time, then ultimately in the long run, the better one is to go with the orange one because that's lower as you see as the months go by. And that's going to be Z Mobile. So Z Mobile, even though initial charge is more, if I'm planning to stay there longer, that is in the long run going to save us more money. All right. There we go. I actually told you I actually did stuff like this to see and to compare like which one is better. All right. There we did all, so we answered all of this over here on the side, and we're going to go on to the next problem. Okay, now we're going into systems by graphing, which we did already, but here there's no context. Okay, and we're just going to straight up do some graphing. All right, so we'll take the first one will be blue. So we're starting again at the y-intercept. This is our y-intercept, not our x-intercept, our y. So we're starting at -4. And again, this is a negative slope. So we know it's going to be going down. So it's going to be in this down direction. So here we go. That's going to be up 1. And then we're going to go to the left to make sure that it goes in this downward direction. It's a slight downward direction, but still down. Remember when we talked about decreasing? So it would be, or you can go the opposite direction, go down and then go to the right 9 right here. And so I'm going to draw my line very carefully. Okay, it doesn't look like I'm doing very good, but I am. As good as I can. All right, and then here we're going to do the second line in orange. If I can get it to go to orange. Come on, buddy. Let's be orange. Okay, did you see that? That's weird. Okay, well, it's orange now. So again, we're going to start at +4. So again, we're not going to x-axis. A lot of people like to switch off. It is never like, it is always the y-intercept. That does not change. Okay, the number by itself is always the y-intercept. And then our slope, remember when there's no number, that means there's that invisible -1. Because we technically have -1 x's is -1. So we're going to go up 1. And then since it's negative, we're going to go to the left. So you should make that negative slope right there. See how it's going down? And do a couple on this side. Okay, let's see. I had my ruler. I would totally not have to draw all of these points, but I don't have my ruler. So yeah, you need to be very precise here. If you notice right here, our solution, so if you just leave it like this, you're not done. You didn't actually solve the system because you didn't say what the solution was. So again, you got to look where they intersect, right? So this is where they intersect, and that's going to be at, let's see here, 9, -5. So 9, -5. That's our solution. That's where they intersect. Now we're done. Good job. All right, again, take some time, pause, try it yourself. Okay, don't just copy down these graphs while I'm doing it, because that's not really going to help. You got to actually sit and try to do it by yourself. I know sometimes it's scary, but you can do it, I believe. Okay, so here we go. Let's try this one. Oh, they really don't want to change for me. I'll just change it here. Let's go dark blue. All right, so this first one is going to be +8. I'm assuming you've paused this and you're trying this yourself now, right? Or you've already tried it and you're just seeing if you got it right. So 8, and then we're going to go 1, 2. Since we can't go up 4, we're going to go down 1, 2, 3, 4. Now, remember, this says it's going to be a positive slope, which means it's going to be increasing, right? So I'm going to have to go to the left to make it sure that it's increasing. 3 to the left. So down 4, 3 to the left, because originally I would have gotten up 4 and 3 to the right. Should have made this kind of angle, you see? It's kind of tilt it's increasing. So 4 down, 3 to the left. 4 down, 3 to the left. Okay, there you go. Draw my line. Okay, and then let's try this light blue. All right, sky blue maybe. So this is at -8. So we're going to go all the way down to -8 on the y-axis. And then we're going to be, I remember our slope is -4. So we know it's going to go down, decreasing. So we're going to go up 4 and then 1, 2, 3, 4 to the left 1. So up 4, left 1. Remember, so you see how the line, when we were to draw it, if we were to draw it, it would be going down. Here we go. And see, do you see how we know where it crosses now? Still draw the line, okay. All right, so from here, this is our solution, and our solution is going to be -3, 4. -3, 4. Please make sure you write it as an ordered pair. You got to put these parentheses around there to show that it's an ordered pair, right? To show it's a point on the graph. All right, and remember x comes first and then y. There we go. So we got solving systems with equations that are in slope-intercept form. But now, what if they're not in slope-intercept form and they're in, what is it called? Standard form. Okay. Again, there are two ways to solve it. Solve it by intercepts or solve it by, what is it called? By changing to slope-intercept form. This, for number 5, I'm going to change the slope-intercept form. And if for you, you're more comfortable with solving the slope-intercept form, great, always do that. But know that you also have another way of finding the x and y intercepts. Okay, it's always good to know more ways than less ways. So I'm going to change this. I'm going to just rewrite this because I don't have much room over there. And we're going to change the slope-intercept form, which means y is by itself. So here we got to get rid of this x. Excuse me. So we're going to subtract x on both sides. There we go. And what we're going to do is we're going to, I'm going to have to change colors every time. So don't forget this. A lot of people forget this negative. We did not deal with that, right? Because that is attached to the y, not for the x. Because negative y is equal to negative x minus 4. I'm going to put the x first. Because normally, you know, mathematician, we like to put the variables first and then the constants, right? There's a little bit of order there. You don't have to. It's just, you know, it's nuts. It makes it look a little better. All right, and then here we go. We still have this negative, so we're going to divide everything by -1. The other way you can do this is multiply everything by -1. Either way is okay. And then we're going to get our answer of y is equal to, so negative divided by negative is positive, so it's just going to be x. If you want to write x over 1, you can, but you don't have to, because what's x divided by 1? Just x. So -4 divided by -1 is going to be +4. All right, so here we go. Here's my +4, and it's a +1 slope because there's no number in front, which means there's that invisible 1. We just have 1x. All right, so 1, up 1, right 1. I'm running into my work now. That's okay. I'm now going to the left to make sure. You don't have to, again, you don't have to do all these points. It's just I have to because, or else I'm going to be inaccurate because I have actually no ruler to do this one. Okay, there we go. Make sure you're not making dinky lines. They have to be all the way across. So we do not know where this other line is going to cross this blue line. All right. So let's go with green here. I'm going to just do the work over here on the right. So we got 7x plus 3y is equal to -18. So our first step is going to be, again, get rid of this x. So we're going to go -7x. And we got 3y is equal to -7x minus 18. Okay, just like that. And then to get rid of the 3, because we have 3 y's, right? We all know how much is for 1 y. We're going to divide by 3. Divide by 3. Everything divide by 3. we get y is equal to 3 does not go into 7 evenly, so we're going to keep it as a fraction. Remember, fractions are okay. People sometimes freak out, but that's fine. They're just fractions. So -7/3 x, but 3 does go into 18 evenly, so that's going to be -6, right? Because there's that minus right there, and 3 is not a negative, so it does not cancel out that negative. All right, so here we go. This is what we're going to graph. We're going to start at -6. And again, this is a negative slope, so we know it's going to be like going decreasing. So we're going to go up 7. Here's 6, 7, and then to the left 3. 1, 2, 3, right there. So up 7, left 3. All right, we're going to make our little so we're going to make our line. Oh, that was a bad line. I'm going to try that again. There we go. Just like that. And again, our solution is going to be -3, +1. That is where they meet. This point is a solution for the top and the bottom equation, which means this point is on both of those equations. Okay, both of those lines. All right, so this is how that number 5 is how we graphed using slope-intercept form. We changed everything to slope-intercept form. On the right, if you see things like this makes it easier to solve it with intercepts. Okay, so let's go. I'm going to continue to use my forest green here. So for this first one, I'm just going to put a little arrow here. We have our x-intercept. So remember, our x-intercept is when our y is equal to 0. Okay, if our y is equal to 0, so this is y is 0, that means it's going to be x plus 0 is equal to 5. Okay, so for your y, remember x-intercept is when it crosses the x-axis. The value of your y coordinate here is 0, always 0. Because if it was 1, it would be up here, not on the x-axis. If it was -1, it would be below the x-axis, right? So, yeah. So for the x-intercept, y is always 0. This concept is very useful throughout the rest of your math career, okay? So when you go into Algebra 2, when you go into Pre-Cal, when you go into Calculus, like this is all, you're gonna have to know this for any function. X-intercept, y is equal to 0, always. All right, so then when we get that, we'll know what's x plus 0. Really easy, right? So it's just x is equal to 5. So a lot of this you can just do in your head. You don't even have to show the 0 part. Honestly, you just know that x equal to 5. For me, I just usually cover up the y with my finger. If you haven't seen me in class do that, then don't worry about it. But x is equal to 0. So and when y is 0, x is 5. So here we go. X is 5 when y is 0. There's my x-intercept. We're going to do the same thing. So for the y-intercept, so now think about the y-intercept is when the x is 0, right? So we would plug in 0 for x. And what do we get? 0 plus y is y, right? Is equal to 5. So y is equal to 5 when x is 0. Do you see how this line goes? We have 2 points. And just draw that line. Looks like this is going to be a slope of -1. Okay, I think I did that right. Okay, we're going to do the same thing for the second one. We'll make it orange. So this guy we're going to put like right here. So x-intercept. I'm going to go a little bit faster on this one. Again, this is when y is equal to 0. So when y is equal to 0, if that's 0, this is going to be x is equal to -4. So x equals to -4. So we're going to graph that as we go. X equals to -4. For your y-intercept, that's when x is equal to 0. And if x is 0, y is equal to -4. Right here. And then we're going to graph it just like this. Oh, that's not great, but that's fine. All right, and what do you guys notice? Where's the solution? If it's like this, it doesn't, right? This, right? That's what we call, because when I'm asking you where do they meet? What point shares the same what line? what point do they share, right? They don't, right? There's nothing that they share. Will they, if we were to extend these lines and we're going to zoom out, right? See those lines, are they ever going to cross? No, right? Because they have the same slope, right? So this is what we call no solution, right? There is no solution. Now, you can pick any X and Y, any point on the green line, and it will never be on the orange line. It's just not going to happen. All right. And if you can find it, I'll give you $1 million. All right. Okay, we're going to do the same thing here. Ooh, now look, right? So if you take a look at this, you'd be like, ooh, I know how to do the top one. The bottom one, top one is in a slope-intercept form. The bottom one is in standard form. We know how to do both, right? So the top one, I will use like what we've been normally doing. Here's where we start, -5. Let's go, -5. Slope is 3/2. I know it's going to be positive. It's going to go up and to the right, right? Because it's going to be this positive slope. It's going to be increasing. Do the other side. I'm as accurate as I can. As accurate as I can be. All right. And then on the bottom one, what I'm going to do is I'm going, just kidding. Still won't let me change it. That's so weird. X out of that. We don't need that. All right. So what I'm going to do is I'm going to solve this by intercepts, just like we were doing. So the x-intercept is when y is equal to 0, right? So if y is 0, 2 times 0, 0. So this is going to be x is equal to 6. All right. Again, if this stuff confuses you, then go and change it to slope-intercept form. Which, you know what? Maybe I should just try that for this one time. And here's my x equals to 6. And then when y is y for the y-intercept, that's when x is equal to 0. So if x is 0, we got 2y is equal to 6. Going to solve for y by dividing by 2 on both sides, and y is equal to 3. So we're going to go up to 3, just like that. All right, so we're going to, that looks like a weird 3. 7, up 3. Let's see here. Where does it cross? So I look at 1, 2. It looks like it would be right here. 1, 2. Yeah, there we go. It's hard to do this without a ruler, but you know. Me too. Sorry, that is not exactly right. Why? Okay. So let me see. Like I said, I was going to show you that this is either way does really work. Let me make it green so that you can see. So again, how do we change this to slope-intercept form? Again, we're going to subtract x on both sides. 2y is equal to -x plus 6. Now we're going to divide by 2 everything. Again, if this is a common mistake is that they divide by -2 because they feel like that should always be negative. It's always the same number as what's in front of the y. If there's a 2, you just divide by 2. If it was a -2, then you divide by -2. So then the 2's cancel out because 2 divided by 2 is y. So y is equal to, remember there was that -1 that says -1/2 x plus 6 divided by 2 is 3. So my y-intercept is 3. Oh, look, y-intercept is 3, right? Same thing. Slope is -1/2. This is definitely a negative slope. And we go down 1 to the right, 2, down 1 to the right, 2, down 1 to the right, 2. Do you see? Exact same line. Okay, just 2 different ways of doing it. Okay, here we go. I noticed right here, just from my own experience, I know that I'm going to eventually have to divide by 4. And this -3 doesn't divide by 4 evenly. So I'm just going to change this to slope-intercept form. Okay, because the y-intercepts are not going to work as well. Actually, either way, but this will just be a little bit easier, I think. So 4y is equal to -3. And we're going to subtract 3x, subtract 3x. 4y is equal to negative 3x minus 3. Divide by 4. This is interesting. Negative 3/4 x minus 3/4. Ooh, this is tricky, but it'll be fun. All right, so negative 3/4 is not exactly 1. It's like close to -1, but just shy of it, right? So we're going to go start at, here's -1 is a little bit above it, like not halfway, but a little bit more than halfway down. All right, and then it's going to be 3/4, 3/4. So we're going to go up 1, 2, 3. Remember, it's a little bit above the 2. And we can go over 4 as the negative, so I would go to left 1, 3, 4. So it's going to be like, that's so weird. All right, and then let's do this again. 1, 2, 3 over 4. So again, notice that I'm making it not at 5. It's going to be a little bit above 5 because it's going, remember, we're starting at negative 3/4. It's not exactly at an intersection. I'm going to do the same thing here. 1, 2, 3, and then over 4. It's a little bit above the negative 4. Not halfway, but anyways. 3 and 4. Okay, let's see. Oh my dear. Okay, there we go. All right. Ooh, that was interesting. So now we're going to do this. The second one is pretty, says slope-intercept form. We're starting at 3. And then we're going to go, it's a negative slope, so up 2, and then 1 to the left. Right, up 2, 1 to the left, or down 2, 1 to the right. Yeah, I think that's where we're supposed to be. And my line was a little higher than usual, right? You can draw one better than mine. I know where the intersection is, right? Okay, this is algebra 1. So we are going to just have intercepts that are just at integer points. If it was algebra 2, we could definitely have fractions and all that. But graphically, you wouldn't do it that graphically with decimals because it's hard to tell what it is with decimals. So again, this would be at 3, negative 3. All right. OMG, you didn't tell me. Maybe you did. I just can't hear it through this video. We didn't do the solution here. We didn't even finish this. What is this? What am I doing? So again, that intersection is going to be at 4, 1. There we go. Now we're down it. Now I'm down it. Did I do that for the other ones? Okay, good. I did that there. So these are graphing, solving systems with a system of equations with graphing. Okay. You don't always want to do that because sometimes you don't want to know how to graph some numbers like this one is 22. Do you really want to do that? That's kind of large, right? So we're going to find some algebraic ways of doing it. And sometimes substitution will be easier. Other times elimination will be easier. Okay. And I'll just show you what in standard, technically you can use either way for any kind of equation. Just sometimes substitution is easier, sometimes elimination is easier. Okie dokes. All right, here we go. When they are in slope-intercept form, I like to use substitution. That for me is easier, so that's what we're going to do. Okay, so remember they're both equal to y, which means that instead of this y right here, we're going to replace it with, don't mean to cross it out. We're going to replace it with this guy. He's going to put it right in there, right? Because we know that they're both equal to y. So we're just subbing it in. So 4x minus 9 is equal to 3x minus 2. Okay? So again, oh, I can't even get highlighters at this juncture. That's crazy. Okay. Anyways, we will continue on our I'm going to just do a different color here. So what we're going to do first, what I like to do is I like to get the x's together, right? I only want x's on one side. So what I'm going to do is I'm going to subtract 3x on both sides. I could have subtracted 4x on both sides, but in my mind, I'm like kind of pre-planning, right? That means I would do 3 minus 4, which means I have to deal with a negative. I don't want to do with that. So I'm going to subtract 3x on both sides. It's like that. So 4x minus 3x leaves us with just 1x, or what we say, just x, minus 9 is equal to negative 2. Right? And then what we need to do here is we're almost done. We almost have the x figured out. So we got to get rid of this minus 9. So we're going to add 9. So add 9. And we're going to get x is equal to negative 2 plus 9 is going to be 7. All right. If it was the last unit, then yes, we could say we're done because we solved for x. Right? But remember, we're solving for systems, which means we need an x and a y. So we got to plug it back in. I'm going to plug it in to the top bottom equation. I think the bottom will be a little bit easier. You can choose whichever one you want. It really doesn't matter because remember, it's going to give you the same solution. So I'm going to use the bottom solution, bottom equation, y equals 4. Instead of x, we're going to put in what we know x to be now. X is 7. So you could either use parentheses or you can use that dot for the multiply. 4x minus 9. Right? It's exactly this bottom equation, except we replace the x with 7. And then y is equal to 28 minus 9. So y is equal to 19. Right? So our equation is, or our solution is going to be 719. Okay? So remember the x goes here, the y goes here. Done. All right, same thing again. Again, you try it out yourself. You got to let your brain process it. Okay, I'm assuming you've done that. And now you press play. We're going to set these equal to each other since they're both in slope-intercept form. Well, okay, I just do 5x minus 11 is equal to negative 6x plus 22. If you wrote it the other way and you said negative 6x plus 22 is equal to 5x minus 11, that's fine. Okay, totally fine. You'll see the exact same, well, very similar steps. All right, so what we're going to do here is, again, get the x's together. I don't want x on the right-hand side. We're going to just take them out. Right, we take it out by, since it's subtract negative 6x, we're going to add 6x to ensure that it cancels out to become 0 x's, which is just 0. So this is going to be 11x minus 11 is equal to 22. Okay, now it's just a two-step equation. We're going to add 11 on both sides. 11x is equal to 33. And we're just going to divide by 11 now. X is equal to 3. And again, we're going to choose one of the equations. This time I'm going to choose the top one because it seems a little bit smaller numbers, right? So maybe a little more simple. So y is equal to 5 times x, which is 3, minus 11. Y is equal to 15 minus 11. So y is equal to 4. So x is 3, y is 4. That's our solution. See how we don't even have to graph it? We could just figure it out just like this. We could have honestly done the same thing here, right? But we had a graph and they wanted us to use a graph, so we did. All right, we got to know how to use it multiple different ways. All right, so here we go. Notice one is in standard form, the other one is in slope-intercept form. Not like what we've done before. So we're still going to use substitution, but it's not going to look the same as what we've been doing, right? So we got 3x minus 3. But instead of y, we know that y is equal to 5x plus 16. We're going to plug that in for y. So instead of y, we're plugging in negative 5x plus 16 equals 24. So let's make it better, equals 24. There we go. All right, equals 24. And now we're going to solve this equation. We have parentheses, so we're going to have to distribute. This 3x has nothing to do with that, so I'm going to write that down first. All right, oh, that's an x. All right, so negative 3, get a different negative 3 times negative 5x is going to be plus 15x. Negative 3 times 16 is going to be minus 48. 3 times 6 is 18, yep, 48. equals, let's go back with the original color, equals 24. Now here we have x's on the same side, which means we could combine like terms. That's just going to be 18x minus 48 equals 24. Again, now two-step equation, right? We've done this many times. Add 48. We got 18x is equal to, that's 48, 60, 72. All right, now we're going to divide by 18. Divide by 18. So x is equal to 1, 2, 3. 3, 4? Let's say 4. Yep, 4. You can check your calculator, right? And so that's going to be 4, and then I'm going to plug that in. I'm going to use, I need to know what y is. I'm going to use the bottom one because it's already solved for y. So that makes it easier for me. So y is equal to negative 5. We know that x is equal to 4 plus 16. So y is equal to negative 20 plus 16. So y is equal to negative 4. And if you're like, how'd you get negative 20? I want you to think about it. Okay, look at what's going on there. How did I get negative 20? So you look before and see using negative, because the plus 16 is not different. So using negative 5 and 4, that's must be where it came from. What did she do? Like, oh, she must have multiplied that, right? So that's how you can get your brain to process things, right? And here we go. So x is equal to 4, y is equal to negative 4. Well, bam. All right, same thing here. It's not slope-intercept form, but it's definitely solved for a variable. So it's solved for x. So we're going to do the exact same thing here. Let me make this a different color so it doesn't get confusing with the one on the left. So instead of this x, we're going to put in y minus 6. We're going to plug it into this x. Okay, so we get negative x, or negative 8, times y minus 6. We know that y minus 6 is the same thing as x, minus 4y equals negative 12. And the reason why we do that is that if we have two variables, we can't solve for x or y, right? It's not possible. So we needed to have it in one variable. So now that we have only one variable, now we can solve for that variable. So again, we got parentheses, so we're going to distribute. So negative 8 times y, negative 8y, negative 8 times negative 6 is going to be plus 48 minus 4y is equal to negative 12. I have these like terms on the same side. Negative 8y minus 4y is going to be negative 12y. Got this plus 48 was negative 12. Again, we're now at a two-step equation because it takes us 2 steps to solve this equation. So we're going to subtract 48, and we'll get negative 12y is equal to negative 60. Divide by negative 12, divide by negative 12. Y is equal to 5. All right, we got y, we need to get x. I'm going to put it in this top one just because it's already solved for x and no need to do extra work here. So we know y is equal to 5, so we're just plugging that in. Minus 6. So 5 minus 6 is negative 1. Done. Do you see how that's easier than using the bottom one? It would work, but it's just a little longer. So again, x is negative 1, y is 5. Done. All right. We have quite a bit more to go. We're going to do some more practice. This one is not using substitution. I mean, you can, but it's not going to be as pretty. Okay, so here we go. Let's try this 13. I notice right here they're both in standard form. This is usually good indication. You can use elimination. All right, this is usually when people use elimination. So we're going to eliminate either the x or the y. In this case, for 13, I'm looking at them. Looks like x's are going to be easier to cancel out because they're already set up for that, right? 3x minus 3x, if we add those two equations together, it's already canceling out. So it's already going to get eliminated. So we like, boom, done. So then I'm going to add these two, the y's up. So 2y minus 4y is negative 2y equals 10 minus 8, which is 2. See, this is really not bad. And then we're just going to divide by negative 2 because our goal is to get y by itself. And 2 divided by negative 2 is negative 1. Done. Now we're going to figure out what x is, just like how we did for substitution. This part is the same. So none of them are solved for already, so I'm going to use the one that looks simpler, which for me is the top equation. So we got 3x plus 2 instead of y, because we know what y is. Y is negative 1. Got to plug in what we know. And 3x, oh, just kidding. So minus 2 equals 10. Again, now it's a two-step equation. We got 3x is equal to 12 divided by 3. X is equal to 4. So 4, negative 1. You see how like a little bit shorter that is? This is probably why a lot more people like elimination as opposed to substitution. Although there are definitely people who really enjoy a substitution. Either way is fine. Okay, here we're going to try 14. Are we going to eliminate the x's or the y's? Either one is okay. There's definitely an easier one in this case, right? If you look at the x's, already done. I'm going to cancel those out. 7y minus 6y, 1y, or just y. 0, 0, right? 0 plus 0 is 0. So y is equal to 0. It's already solved for. Nothing else to do. All right, so now I'm going to use the top equation. So 6x plus 7 times 0 is equal to 0. I have a feeling what's going to go on. 7 times 0 is 0. So all we have left is just 6x is equal to 0. Divide by 6, x is equal to 0. So your answer is 0, 0. Right. So they literally intersect right at the origin. Not that fun, but I mean, totally works. All right, so here we go. Let's try this one. Okay, this is a little different. They are not the same. I noticed that right here, y is by itself. So I'm going to just multiply this bottom number by negative 7 so that I can get them to cancel out. So I'm going to multiply the whole bottom number by negative 7. Okay. I would have done a positive 7, but then that would not cancel out because 7y plus 7y is just 14y. It's not 0y. So here we go. I'm going to just copy the top part right there. Let's make that top equation orange. So 2x plus 7y is equal to negative 23. And then we're going to go back to our green color. And negative 7 times negative 3x is going to be 21x. Negative 7 times y is going to be negative 7y is equal to negative 7 times negative 23, which is positive 161. It's 161. All right, so here we go. Now we're going to add these equations up. 2x plus 21x is going to be 23x. My y's cancel out, and all I have left here is 161 minus 23 is going to be 138. Divide by 23, divide by 23. X is equal to my calculator. Okay, 1, 2, 3, 4, 5, 6, maybe 6. 138 divided by 23. I don't know if you can see that, but 6. All right, there goes 6. So I'm going to use the bottom equation. Bottom equation because y's seems simpler to me. Negative 3 times 6 plus y is equal to negative 23. So that's going to be negative 18 plus y is equal to negative 23. So add 18 on both sides. Honestly, at that point, it's a one-step equation. Y is equal to negative 5. There we go. See, y is already we don't have any coefficients for y, so it saves us a step. Good choices. Okay, so it's going to be 6, negative 5. Woohoo! That's parentheses there. All right. Moving on to 16. Again, pause, try it yourself. I am going to cancel out the y's just because I know that 2 times 2 will give me the 4, so very few things to do. Let me change it to pink. Let's go pretty in pink today. And I'm going to multiply by -2 so that I would get that -4. So my y's would cancel out. All right. And I'm going to blue. So my top equation is going to be blue. So -6x plus 4y. We're not doing anything to it. So I'm just copying it down. And then my, go back to pretty in pink. And we got -2 times -8x is going to be positive 16x. -2 times -2y is going to be -4y. Equals -2 times 26 is going to be -52. Cancels out the y's. Woohoo! And we get -6x plus 16x is going to be 10x is equal to -30. Divided by 10. X is equal to -3. Now I'm going to solve for y. I am going to use the top equation this time. And I'm going to go -6 times -3 plus 4y is equal to 22. And that's going to be 18 plus 4y is equal to 22. Two-step equation, subtract 18. You get 4y is equal to 4 divided by 4. Y is equal to 1. So we got -3 and 1. That's our solution. They done. Oh, my dear. Okay, so let's. Oh, no. Oh, that's fine. I didn't put in what I thought I'd put in, and so c'est la vie. I thought I would. Never mind. Notice right here, 12 doesn't go into 25, 3 doesn't go into 5. We're going to have to multiply both equations. I'm going to use the smaller numbers just because then I don't have to multiply by such big numbers. 3 and 5 both go into 15. This is where knowing your multiplication tables really helps. You can list these out so you can do the multiples of 3, 6, 9, 12, 15, 18, right? You could do the multiples of 5. So 5, 10, 15, 20, 25. And then you can see what do they have in common, right? And the first thing they have in common are these 15s, right? That's what we call the least common multiple, okay? So the thing about those words, least common multiple, it actually makes sense why it's called the least common multiple. But anyways, something for you to think about. So we want to make them 15. So we already have one of them being negative, so that's good. So I'm going to multiply 5 times 3 is 15, right? And for the top one, we'll make that blue. And 3 times 5 would give us 15 as well, right? So here we go. So 5 times 3x is going to be 15x. And it's working 5 times -12. Here we did the first one. 5 times -12 is going to be -60y equals 5 times -18 is going to be -90. Right, and then we're going to go with pink. All right, 3 times -5x is going to be -15x. See, this is what we want, right? 3 times 20 is going to be plus 60. 3 times 30 is going to be 90. Oh, you may have noticed. See what I see, right? So 15x minus 15x is 0. Well, -60y plus 60y is 0. All we have left here is 0 is equal to, well, -90 plus 90 is 0. Everything canceled out. What does that mean? Those two were actually the same line in the sky. They're trying to pretend like they weren't, but they are, right? So they are exactly the same thing. So this is what we call, and we know that 0 equals to 0. That is definitely true. So we call this infinite solutions. I like to call it infinitely many solutions because there are infinitely many solutions. But we can call it infinite solutions because that's what the book's been calling it. Infinite solutions. All right. Oh, and that's your answer. Yeah, that's all. We can't solve for x or y because they all cancel out. Every x, y, that if it works for the top, it's going to work for the bottom. So there we go. Here we go. Let's try this one. Notice the same. We have the same situation here. I know it's a 3 and 5, which is smaller than the 6 and 7. We already know the thing for 3 and 5, right? So I'm going to multiply the top one by 3. I'm going to multiply the bottom one by 5. We already have one of them as negative, one of them as positive, so we're good to go. Good to go. All right, so let's multiply this out. 3 times negative 7x is going to be negative 21x. 3 times negative 5y is going to be minus 15y is equal to 3 times 27, which is going to be 81. Okay, I should have known that a little bit more. But anyways, here we go. And then the bottom is 5 times 6x, which is going to be 30x. 5 times 3y is going to be plus 15y is equal to 5 times negative 27, which is going to be negative 35, 10, 13, 135. Boom, cancels out. And we get, that's going to be 9x is equal to 7. No, why can I think? OMG. Okay, negative 5, negative 54. I was going to say negative 54. I'm like, nope. Divide by 9 on both sides and we get x is equal to negative 6. Okay. Now we need to find the y. Because we have an x, so we got to find the y. I'm going to use the, so negative 7 times negative, if you chose the bottom one, that's good. We should get the same answer. So if we didn't, we did something wrong. So negative 7 times negative 6 is 42 minus 5y is equal to 27. So subtract 42 on both sides. You get negative 5y is equal to negative 15. Divide by negative 5, y is equal to 3. So we get negative 6, 3. That's our solution. Woohoo! We did it all. Okay, now we're going into the world of inequalities. Before we were on equations, which is equalities. This is inequalities, which means we're dealing with these guys. Say cheese. No, I'm just kidding. All right. So here we go. We're going to start with just one inequality, and then we're going to go on to two system of inequalities. And then we're good to go. All right, so let's take a look here. So here we have, we're going to just graph it like how we've been graphing it. It's in slope-intercept form. So here's our negative 2. Negative 2. Our slope is negative 4. 1, 2, 3, 4. And to the left one, because it's negative, we want this negative slope like this. And now the question is it solid or dotted? Remember that bottom? So if it looks like this, it's an equal sign, right? And if we put a boom like that, that's called a less than or equal sign. So it's both of those. I'm not asking you to choose. That the name of it is less than or equal to. Okay. And both conditions work. As long as it's less than or equal to, we're good. Like it's a solution. If it's not, the only thing it can't be is it can't be greater than, right? So this is less than or equal to. If there's equal to there, then we know it's a solid line because we're including the line. If it's just less than, then it's going to be a dashed line, or what I say in class is solid, dotted, right? Dotted line when it should be a dashed line, you know what I mean? And so here we go. Here we have, it can be equal to, so it's going to be that solid line, just like this. And then I guess the other question is then, which way is it going to go? It says y is less than. Okay, there are two ways to do this. You can either pick a point and choose and test the point to see if it's a solution, or you can think of it conceptually. Okay, so first thing we're going to try is, well, I'll show you conceptually first. So do you see where, okay, I should have had the line cross right here at negative 2. Sorry for my poor drawings here. Do you see how it cuts this y-axis into two parts, right? We have the top part here and the bottom part here. So it says that y is less than this line, right? The negative 4x minus 2, that's what we use to create this line, right? So where are the y values less than this line? And it would be like negative 3, negative 4, negative 5, negative 6, right? That's all lower numbers, right? These are numbers lower than this line. So we're going to shade on this side. because that's where it's less than. Y is less than it, right? So that means any point on this top part or to the right part is not going to work. Let me show you. So for example, we normally pick 0, 0, right? So if we were to pick 0, 0, this should not work in this inequality because we said because 0, 0 is on the opposite side of where all the solutions are, right? So again, let's plug it in. So we've got 0 for y is less than or equal to -4. X is going to be 0, right? Because that's the x coordinate of 0, 0, -2. And we don't know if that's true, so we're going to put a question mark over it. So y is less than, or 0 is less than or equal to -4 times 0 is 0. 0 minus 2 is just -2. Is 0 less than or equal to -2? Is it less than? No, 0 is not less than that, right? It does not work, right? Do you see? And we knew that 0, 0 is not going to be a solution. So if we tried this first, if we know that 0, 0 is not a solution, where are all the solutions? On the other side. So that would be over here on this side. So either way you want to do it, but this only works when you have it in slope-intercept form. It does not work when it's in standard form like 21. Can't do that unless you change it to slope-intercept form. And then you can use that form. All right, so let's try this one, -2. Start at -2. Our slope is positive 7/3, so we're going to go up 7 to the right 3. And that's going to be, is not equal to, so it's not equal to the line. So it's going to be a dashed line. So my dash doesn't look that good. So dashing, right? It says y is less than, right? Y is less than, so less than is where the y numbers are going smaller. So this is going to be our solution area. So anything down here is kosher. All right, that's going to be our solution. If you just do the dotted line and then have no like shading, you didn't finish it. Like, because all these points over here are solutions. We have like a gazillion solutions, infinite number of solutions. Okay, so here we go. We're gonna do the same thing, but now we have standard, it's in standard form, right? So I am going to change this to slope-intercept form, just for you. If we were doing by intercepts, it's not gonna be pretty. There's -5 divided by 3. Does not go unevenly. So I'm going to just change it to slope-intercept form. So again, I'm going to subtract 3x just like how we've been doing. Okay. All on the previous ones from above. So -y, don't forget that negative. It's greater than or equal to -3x minus 5. I get rid of that negative. Do not say divide by -y. Leave the y alone. We don't want to get rid of the y because we want the y there, right? We're just going to get rid of that negative. We do that by just dividing by -1. That's going to just get rid of the negative, and we got y. Now remember, we divided by a negative number, which means we got to flip the inequality, right? And then -3 divided by -1 is 3x, and then -5 divided by -1 is +5. So we got y. Okay, this is +5, so we're going to go up to 5. Our slope is 3. Normally we would go up 3 into the right one, but we can't. So we're going to go down 3 to the left one so that we have that positive slope there. Down 3. And it's going to be solid or dotted? You guessed it. Or you got it. I'm sure you didn't guess it. It is solid because it can be equal to, right? We have the equal to sign underneath. It says y is less than. So we're going to be, this is all where y is less than. Normally I would use my highlighter, but I'm having issues with these colors here. All right, so it's everything down here, right? Which means is 0, 0 solution? Yeah. So if I were to, in my brain, plug in 0 here and 0 here, 0 is greater than or equal to -5. Is that true? Yeah, 0 is bigger than -5. See? Works. Solution. Done. All right, same thing here. Let's see. So 5x plus 2y is less than 0. Let's subtract 5x on both sides, get this to a slope-intercept form. I get 2y is less than negative 5x. I could say plus 0, but I mean, okay, fine, I'll do plus 0. You don't have to, right? Because it's just negative 5x, right? But divide by 2, divide by 2, divide by 2, y is less than negative 5 over 2x. Well, what's 0 divided by 2? 0. So normally we would just write it like this. And you see how we would not have that plus 0 there? And so whenever you see something like this, you're like, oh, right, there was that plus 0 there that we didn't have to write because it's just 0. It's just negative 5x, negative 5 over 2x. All right, so here we're going to start at 0, right? And then we're going to go negative 5 over 2, up 5, and then to the left 2 to make it negative. It's going to be solid or dotted. So you guys be like dashed, mostly dashed. All right, there we go. And it says y is less than, right? Y is less than, which means that it's going to be less than. So all these y numbers are below this line, not above this line. So it's going to be this way, like this, less than. We can't even pick the point 0, 0 here because it's on the line that's dashed. So we know it's not going to work and it's not going to tell us which side. So you could use, like, I would use like 1, 1, and I know that that should not work. So if we're to put a 1 here and a 1 here, that'd be 5 times 1 is 5 plus 2 is less than 0. Is 7 less than 0? No, not true, right? Which, this is not a point on the line. Or not a solution, I should say. All right, good job. Okay, so here we go. Let's see how many more we have. That's it. We have 6 more problems. Oh, my dear. Okay, so write an inequality that represents each graph. Okay, so here we go. I'm going to start with my slope-intercept form. So y. I'm not sure. Okay, it is going to be, see how the numbers are going up? So I know it's going to be greater than. It's going to be equal to no because it is dotted. So I'm going to leave it like that. And what's my y-intercept is at negative 4. So I'm going to write over here negative 4. I know there's an x there, and I don't know what the slope is. Find another point. Ooh, this point right here. Up 1, 2, 3 over 1. Let's see if that's true. Up 1, 2, 3 over 1. Oh, good. I land on the line again. So I know it's going to be 3 over 1 or just 3. So there is my inequality. See? Not that bad. Going on to the next one. Let's try this one. So it's going to be y. See how it's going down lower? So it's going to be less than. I have a solid line. So that's equal to. My y-intercept is at negative 5. So I'm going to be like minus 5. Here's my x. And my other point, right here. So it looks like it's going to be up 2 and to the left 3. This is a negative slope, so it's going to be negative 2 over 3. Done. All right. See, those were the quickest problems ever. So now we have a sketch the solution to each system of inequalities. All right, so we're just doing 2 on one graph. So here we go. Here's plus 6. We're going to go negative 3, so down 3 to the right 1, or up 3 to the left 1. I'm going to do this a couple of times because I got to be pretty accurate here. And this is going to be a solid line. There we go, all the way across. And I know this is greater than, y is greater than, so all these numbers up here are going to be bigger than, so I'm going to be up here. All right, I'm doing arrows right now because our final shading is going to be after we do the second inequality. So we're going to call that blue, and we're going to start at negative 5 on the y-axis, and then 2/3. So up 2, right 3, up 2, right 3, or down 2, left 3. And this is going to be dashed because it cannot be equal to. So here it is dashed. All right, and it says y is less than. So that means y has to be smaller than. So we're going to go down like this. You know, it's somewhere down like this. So do you see how it got cut into like 4 regions? Where are both colors pointing to, right? So we got, so this upper right hand, only the purple is pointing to it, but not the blue. So it's got to be this. See if we can get a highlight. Nope, I can't get a highlight really. It's going to be just this region right here, right? Because that's the region that both of them are pointing to, right? That's it. You're only shading one region that works for both. All right, so let's get started on this next one. Again, plus 6 up here, 4, 7. So it's going to be up 2, 3, 4, to the right 7, or down 4, and to the left 7. That is going to be a dashed line. This is not equal to, and then we have x is less than less than or equal to -7. So here's -7 on x. So this is where x is all -7 right here, this whole line right here. And it says x is less than that, right? So x has got to be this way. You know, we're pointing this way. And then, oh, we forgot to do the top part, sorry. It says y is less than, so we know it's going to be somewhere down here than the orange line, right? The only place it's both pointing to is this little portion right here. Again, if we were to zoom out on it, it'd be like this huge portion, but we're only seeing just this little part of it right here. All right, last two problems, and then we're on our way to good. All right, so we're going to have to change these to slope-intercept forms. Here we go. Again, you can use intercepts, but I'm not going to show you that right now. So x minus 2y is less than a -14, so we're going to subtract x on both sides. And -2y is less than, and -x minus 14. Is divide by -2 on everything. Remember, when we're dividing by negative, that switches our inequality. And negative divided by negative is positive. That's just going to be 1 over 2x. That 2 does not go to the top magically. It just stays on the bottom. But don't forget there's that invisible 1 up there. And then this is going to be -14 divided by -2. There's going to be +7. We're going to go up here to 7, 1/2, and 1 over 2. This is going to be a dotted line technically. I have a dotted line already, but it's going to go like this to a dashed line so people don't get confused. Got our dashed line, and it says y is greater than, so we know it's going to be somewhere up here. It's above, right? You could always test a point if you don't know. And then we're going to do the second inequality, so we'll make that blue. And that's going to, I'm going to write it over here. So 6x minus y is less or greater than or equal to 4. Subtract 6x on both sides. That minus y is greater than or equal to -6x plus 4. We're going to divide again by -1 because we can't have that -y. So y, got to flip the inequality because we divided by negative. 6x minus 4. So we're going to go to -4. We're going to go up 6 over 1, 6 over 1. And it's going to be a solid line. Just like that. It says y is greater than, right? Or y is less than, and less than is going to be to the left of this. So here's the question. What is to the left of, is above this orange but to the right of the blue? It's this little portion right here. And we don't see very much of it, but that's where it is. Okay. It's not a very big portion there. And as you can see in the answers, it's right there. See that little portion? That's it. Again, if we're to zoom out, it'd be much bigger. All right, we don't got time. Got things to do, people to see. All right, we'll try this again. Last one. I'm going to do this one with intercepts just because it makes it easier. Okay, actually, you know what? I'll do what I said I was going to do. So x minus y less than or equal to 8. For me personally, I would just do these by intercepts, but I'm just going to do it this way. Here I am. And then we're going to divide by -1 on everything. So y is going to be greater than or equal to. Remember, we flip it. x minus 8. We're going to go to minus 8, and that's a positive 1. So we're going to go up to the right positive. All right, and that's going to be a solid line. That it can equal to. There we go. And then we have y is greater than, so we know it's going to be above this line. All right, last part right here. We have, I'm going to write it over here, 9x plus 4y is greater than or equal to 20. Let's subtract 9x, 4y is greater than or equal to negative 9x plus 20. You see that? All right, divide by 4 on everything. I'll write it over here. So y, I didn't divide by negative, so I'm going to leave it. It's greater than or equal to negative 9 over 4x. 20 divided by 4 is 5. So I'm going to go to 5. Go 9 over 4. So I'm going to go down 9 and then to the right 4. Boom, just like that. It's going to be a solid line. Yeah, both of them are solid. Let's do this. There we go. And it says y is greater than. So these are where all the y values are bigger than. So where am I shading, guys? Up in this region right here. Okay. We're golden. So keep on practicing. If you need to print out another one of these or ask for another copy and then just do some more practice, that would be ideal. All right. Have a good one. Bye.